In this section we need to talk about how we can make our reg application better. A lot of people understand that if we upload data in a vector database, we will only get good answers back if the data is good. And right now I want to give you a lot of tips, and over the next video we will dive into detail. So let's just see, using vector databases efficiently or also using reg efficiently. It's always all about the data. And the first thing is, of course, that you need data. If you want to train a reg application, I hope that you get that you need data. If you want to do this for other people, you need to ask for the data. You can search the data, or you can also scrape the data. And in the next video I also want to show you how you can do scraping. But one thing here, you need to do this ethically. So please only scrape web pages that are allowed to scrape. Normally, like documentations and so on, you can always scrape them. People want that you scrape them. People want that you share the information about this. But maybe like on GitHub, it's not really allowed to scrape. You should always ask if it's legal to scrape this. So if you want to scrape, read the terms of use if it's allowed, or you can also do something like this. If you go, for example, on youtube.com and then you type in /robots.txt, you see what's allowed and what's not allowed. Basically, nothing is allowed at YouTube. And the same thing is true for GitHub. If you type in github.com/robots.txt, you see that a lot of stuff is basically not allowed. So you always need to type this stuff in. If you don't find anything, you should also read the terms of use. But normally, like on most documentations, like from LangChain, or maybe if you work with somebody, they will tell you, hey, it's allowed that you can scrape. So this is important. So first you need to get your data. Ask for it, and if you ask for data, you will not get clean data, you will get most likely PDFs or text files or something else. You can search for the data, of course, or you can scrape it, and then you do it ethically. The next important thing is that you do not store unnecessary data in your application. So you do not want to have unnecessary data in your vector database. Only insert relevant information. Avoid unimportant or redundant data. This is really important so that the data is a little bit smaller and more concise. Q&A and Markdown as the optimal format. Question-answer pairs simplify search. So this works really great. If you have Q&As, this is perfect. Store it in a text file and there you go. Store compact, directly accessible information. And convert please bad data into Markdown. I will show you exactly how you can do this. You can summarize long texts, of course, extract essential points. Here you can also use, for example, LlamaParse. I will show you these. Or you can use a normal LLM. You can use ChatGPT or Gemini. Gemini is great because Gemini has a gigantic context window. Use shorter chunks for better search results. Don't worry about chunking. I will talk about this later in detail. Then use the right chunk size, overlap and text splitter. Like I said, we will go into this in detail, but for a general rule, balance detail, depth and efficiency. If the chunks are too small, you miss out maybe some information. If the overlap is too small, you miss out maybe some information. If the chunks and the overlap, you can also say like this, and the same thing is here true. So basically, if chunks and overlap is too big, you will have lower retrieval quality. It's slow and it's expensive. So you need to balance this out. There is no hard rule because you need to test these things out. Test the bot with queries. Check if the desired answers are retrieved. Adjust chunking or structure if needed. So basically this is the overview, and in the next video we will go into more detail. We will talk exactly how you can scrape, how you can get data, how you can make data into Markdown, how you can use LlamaParse, Firecrawl, Julia, how you can make summaries with LlamaParse, chunk size, chunk overlap, and embeddings. So you will basically be a reg expert after these videos. See you in the next one. Data from the real world is of course messy, especially if you deal with, for example, HTML or PDFs. And that's why I want to show you in this video a lot of cool overviews how you can convert PDFs or HTML into Markdown. Because with Markdown we can work a lot better. So let's just start with the simplest ways of them all. Let's just say you want to scrape the LangChain documentation. If you press on LangChain and we come onto the documentation, like from LangGraph for example, You see that this data is of course messy. This is not good structured for a LLM, so basically this is not perfect. And right now I want to show you how we can get the HTML and then how we can convert this HTML into Markdown. If we simply come into Embedding and press create new workflow, you can press plus, we use a manual trigger, then we press plus once again, we use a HTTP request node, you can press on these. Here we use get as the request, then we need to use the URL, so we would simply copy this URL here. We come back into Embedding, insert this URL, authentication is none, all of this works. If you simply press that step, right now you get in the table you see all the HTML code from this web page. And of course this is gigantic. This is a little bit of a mess. If you go here on JSON, you see that you also have all this data. And basically here are the links and everything is included. This is a little bit of a mess, to be honest. Basically, this is the first thing how you can extract all of this as HTML. Also with this HTML, you can eventually make a rec application or something else. But if you really want to scrape them, maybe also want to extract like links and so on, I want to show you something cool, because Markdown works a lot better. You can press plus and now you can simply type in Markdown and you will find this thing right here. Convert the data between Markdown and HTML. You can press on these, then you want to have HTML to Markdown of course, and the HTML is of course the data that comes here through, so you can insert it, and if you press that step, right now you have Markdown. If you come on JSON, this is now perfectly structured for an LLM. So you can also simply use this, for example, to train your rec application, and it will work a lot better if you have good data on this web page. If you just have a lot of links, of course, you can scrape these links. You can add, for example, an AI agent node and simply extract all of these links. But basically, this is how you can make HTML to Markdown extremely fast. And with this Markdown, you can train rec applications. If you have good content in it. If you only have links, congratulations, right now you know how to scrape them. Another way is this right here, Firecrawl. Also with Firecrawl you can basically do the same thing. If you use here, for example, once again this documentation and you press start for free, you can simply get all of this back into Markdown. So right now you see we have this whole documentation into Markdown, and with this Markdown format we can train an LLM of course a lot better. This works really great. You can also use JSON. So basically this is something that you could eventually use for a rec application. It works a lot better. You can also make a summary. You can use AI to extract sublinks and so on. This is how you can get Markdown. The next thing, a lot of people like to use tools like Julia. Julia works especially for HTML to Markdown, so this is also something that you could consider. And right now I want to show you how you can do this with PDFs, because a lot of the time you simply have a PDF and the PDF is never ever perfectly structured. I like to use this Doggo PDF as an example because I think this is a great example. Here you have pictures, you have text that is not good formatted. This is basically, it's a mess. This does not work great for an LLM, so you see also to copy this stuff doesn't work great. These pictures are included. If you have PDFs, like please make sure to make these PDFs into a good format. And what you can do in order to make good formats out of these PDFs, you can use something like this. You can simply type in PDF to Markdown, and if you simply throw this thing in here, you can make Markdown out of these. Boom, there you have it. Here is your whole Markdown, and with this Markdown you can work a lot better. If you press on edit, you see this right here is the perfect Markdown, and you can use this Markdown, throw it into a text file and upload it, for example, in a rec application. This is something that works great. A lot of other people also like LlamaIndex. LlamaIndex also works great and is especially for LLMs. If you come here to parse, you can simply do the same thing. If you have a URL that links to a PDF, you can give the URL here. And if you have your document, you can upload your document here. And then you can also give some specific information. Should it be fast? Should it be balanced? Should it be premium? What to parse. If you press on it, here you give, so for example, some target pages. If you have target pages, then the job options if you want, and show advanced settings. Here on the advanced settings, you can also type in a little bit more stuff. Maximum 100 pages, for example, bounding box top padding. If you want to have specific formats, make all HTML elements visible, so you can also try this with HTMLs and do a lot more. But I want to make this fast. You can simply press parse, you will wait a tiny bit, and then you will get everything back into Markdown, and this Markdown also will work once again a lot better, just like this thing in Markdown here. So boom, there we have it. Right now we have perfectly structured Markdown. And if you see it right here, we have basically nearly the same thing, but I think LlamaParse does even a better job to extracting the information exactly perfectly structured for an LLM. So if you have a messy PDF, please try to use LlamaParse on this online webpage. It's really that easy. And in the next video, I also want to show you how you can use LlamaParse, but in a Google Colab notebook. This Google Colab notebook has a lot of advantages, because with this Colab notebook, you can extract even more. Not just 100 pages, you can go up basically however you want. At a specific time point, I think you have to pay. But then I have also included something really cool. If you have a gigantic amount of data, you can also compress this data. You can make a summary and train the LLM on the summary. This is also really, really great. So in this video, you have basically learned that real world data is messy. A PDF with pictures doesn't work great. A web page with a lot of links doesn't work great. You should make this into Markdown, and then you will get answers that are a lot better. And if you want to extract information from an HTML page, first of all, you can scrape this page. You simply use this N8N workflow, and then you should also use Markdown, so that the LLM finds exactly what it needs to find. All of this HTML code is not perfect for the LLM, and if you want to scrape all the sublinks, of course you know how to do this. You can also simply throw an AI node on it and extract the information that you want, for example, every link. So basically, this was a 2-in-1 tutorial. You can scrape HTML web page with these workflows. You can make this HTML into Markdown, and if you want to go on with these links, you can do whatever you want, or you can simply train a rec application if you have good data. And you can do the same thing with PDFs. I gave you a lot of options, so choose your option wisely. And in the next video, I want to show you how we can use LlamaParse in Google Colab and also eventually make a summary. Then you have everything that you need to find data, to extract data, to give good data quality so that you get good rec applications. See you in the next one. In this video, we will take a closer look at a tool that is called LlamaParse. LlamaParse works with the LlamaIndex. So all of this is coming from Meta, but it's all completely open source. Our goal is, of course, to convert a PDF file, a CSV file, a Word document, or whatever in Markdown, because we can use these Markdowns a lot better to train our LLMs, to train our rec pipeline. So the first thing that we need is, of course, a PDF. And yes, this is an old PDF. This is an older 10K filing from Apple. And you see, like, it's a mess. This is not perfectly structured for an LLM, so you see all these numbers, there are links, there is stuff that is not perfect for an LLM, and if you scroll down, you have of course some tables later. So here comes the table, and also the table is not in a good structured manner for an LLM. Then we have also some graphs and pictures, so this is something that the LLM cannot do anything with it, because you cannot click on it. So this is really, really awful structured for an LLM. Of course, this is an old PDF, this is just an example, and of course you can use your own data. It can be whatever, it can be every single PDF that you want. I just want to tell you, this is not perfect for an LLM. We need to have this in Markdown. And in order to do that, we use this Google Colab notebook. And I have to tell you, I have found this Google Colab notebook, I think, from a guy on YouTube. But I am not remembering his name. But I think I have found at least a part of this Colab notebook. Down here I have added something in the code, and I have extracted some other parts from the code, and here I will show you what we do in this nice little Colab notebook. The first thing is, of course, we pip install LlamaParse. Google Colab, by the way, this is simply the cloud interface from Google, so Google borrows us some GPU and we can run code here. And it's really, really that easy. You can copy this Google Colab notebook in your Google Drive. In order to do that, you simply press on File, And then you press Save Copy in Drive, and you have this Google Colab notebook in your Google Drive. And then we need to install LlamaParse. So we press play on this cell. Here is some code running. So don't be bothered by this code. We don't need to understand this code. This code is simply running. There is running some Python code. This is always, if you see something like pip install, we always install something. So now LlamaParse is installed. And if you scroll down, now we can, of course, upload our PDF. The PDF that I am uploading right now is this PDF here from Apple. But here you can simply give every single link that you want. Everything that you have to do is, of course, to press on these files right here. Here you need to insert your data, so you can simply drag and drop something right here in it. I have already done this, and then you simply press on these three dots, you press copy path, and you can insert your path right here. And then you simply press play on this cell, and all of it will get uploaded. So right now everything should work. You also see it here right now, so Apple 10K PDF is now uploaded, so you can also just search for a PDF and copy this link and simply insert it. You can either do that, or you can simply drag and drop it and insert the file path right here. Then of course the next one. Here we need to import some stuff so that it is working, so we simply press play on this cell. And now the next step is important, because we need to have a Llama Cloud API key that we need to insert right here. And in order to get that API key from Llama Cloud, we need to go to Llama Cloud. So we go on this link right here, cloud.llamaindex.ai/API key. And if you are the first time on this webpage, you need to make an account. You simply can't log in with Google. Then you press generate new key. We need to give this a name. Let's just say parse, and I press create new key. And of course I will delete this key later. I rotate my keys all the time, so there's no point in copying this key. But I want to copy this. Then I go back into my Google Colab notebook, and then we need to insert my API key right here where this command stands. Your Llama Cloud API key here. So we delete this, we insert my key, and then we are ready to rock. We simply press play on this cell. Now the next cell simply tells us that we want to have everything as Markdown, and we want to have the Markdown from our loaded data. The loaded data comes from content Apple 10K PDF. So of course it's this thing right here. Here is my file, so we simply press here on these three dots. We simply press copy path, and we need to insert it here. I have already done this. So we press play on this cell, and then everything will get included, and we get everything as Markdown. And then of course we can press play on this cell, and we can see all this PDF. So you see we have right now every single thing as Markdown, so all of it works completely perfect. We have everything as Markdown. But of course this is not structured in a way that is good for us. So we simply scroll down a little bit more, and here we can print out our document as text file, and here we simply print 1000 characters. You can go like down to 100 or 500. This is just that you see how all of this is looking. Let's just start with 100. And if you press play right here, you simply see the first 100 letters from this document. Let's just say you want to see 1000. We press play once again, and then you see how all of this is structured. This is of course perfectly structured for an LLM. This is the stuff that we need. And the next step is of course that we need to download this text file, and we can do that with this cell. So we download the 10K, but right now in .md, so this will be a Markdown. If you press play right here on this cell, this will appear right here. If it does not appear immediately, just press here with the refresh button, and then you have it. So the PDF, this is the normal PDF, and then we have also the Markdown, and I want to download these. So we press download, everything will be downloaded on my PC. So I go, of course, into my downloads, and I can open this up, and I want to open these with my editor. And it's actually this file right now. So you see, here is all my stuff as Markdown. And this is of course a lot better for the LLM to digest. So if I open up my PDF file, I just want to show you the difference. So this is the PDF against my Markdown text. Let's just make it a little bit clearer. So you see, this text, this is perfectly structured for our LLM. The tables, they are perfect for our LLM and not such a mess. And if you scroll down more, of course, every single thing will just make a lot more sense for the LLM. It's perfectly structured for the LLM. Of course, there is no pictures, there is just plain text as Markdown, and you have every single thing saved in this file. And also the tables, they are a lot better for our LLM. But of course I have to tell you something. Most of the time there's a lot of fluff and we don't want to fill up our whole entire vector database. And that's why we can make a summary out of this file, and it is really easy to make this summary. And in order to make a summary, we can use this right here. This next cell will make a summary out of our text. The result type is of course Markdown once again. This is the prompt, so we use AI to make this summary of course, and the AI gets this prompt. This is the Apple annual report, make a summary. And the data is of course this thing right here, so we simply press play. Then the parsing will start and we will get a summary that is made entirely by AI with our API key from the Llama Cloud. And my job is now done of course, and the last thing that we need to do is of course to download these, and the file name will be apple10k instructions.md for Markdown, but you can call it however you want. So if you simply press play once again on this cell, this thing will get included also in your content here, so you see it down here, apple10k instructions Markdown. If I press on these and if I download it, I can open this up with my editor. And now we have our summary. So if I make this big, you see, or at least you should see, that this is a lot shorter. Yes, you see it also here. So here, if you see on the right side, this thing is a lot smaller than this thing. So here we have a lot less lines. We have simply the summary from our file. Yeah, I hope you can see it. So this is now a lot, really a lot shorter. This is our original. I think this is like roughly half amount of the text. And this is our summary. So the summary is of course a lot shorter, and this makes a lot of sense if you want to train a perfect RAG application. So this is of course the perfect thing if you want to train a RAG chatbot, for example on books. If you have, for example, a PDF with 100 pages, with 200 pages or something else, you should make it all in Markdown so the pictures, they get excluded. Then of course you can throw it into LlamaParse, and lastly you simply make a summary. It's really that easy, and then you can train your RAG application. The last thing that you need to take a closer look is of course chunk size and chunk overlap, but more on that in the next video. And as soon as you have everything as a summary or as Markdown, you can simply come into your Google Drive. You would come, for example, into this RAG application. You can upload your text file here. And then our automation will of course upload all of it automatically in a vector database. And of course, if you want to make a new vector database, you can create a new workflow with a new folder. You can also use this and simply change in what pinecone vector database this thing should get saved. But I hope you understand how powerful all of this is. In this video you have learned how you can use LlamaParse. I will give you one last time a quick overview of the notebook. So first you go on this notebook, then you can copy it in your drive. You simply press File and you save a copy in your drive. Then this will be saved up in your drive. First you need to pip install LlamaParse, so you press play. Then you can insert of course the link from the PDF that you want to use, and you press play. Then you need this right here. This is just that all of it is working in Google Colab. You press play. Then you need your API key. Of course, you will find it in the Llama Cloud. Then we use LlamaParse to make Markdown out of our content. And the content, you will see the content here. Then we simply print it out, just that it is a little bit nicer for us. Then we print it out as a text file that we can download, and this is the whole file. But you can also make a summary if the file is really big, for example a whole book. And lastly, you press play on this cell because here you can download your summary. And then you are ready to rock because you have your PDF, your CSV file, your gigantic file made in perfect Markdown with LlamaParse. This is one of the best solutions that you can use if you want to train a RAG chatbot. Your RAG pipeline will be on a complete new level, and in the next video I will show you the last thing that is important, because our raw data is now perfectly structured for our RAG application. So see you of course in the next one, because in the next video we will talk a little bit about chunk size and chunk overlap. This is the last thing that you need for a perfect RAG application. Let's talk about chunk size and chunk overlap. These are two concepts that we need to understand if we want to make a RAG application. Now, generally speaking, these two things, they can make your RAG application better. First, I want to tell you a quick problem with these RAG applications. I want to show you something. So we go here, of course, in Paint, and let's just say your document looks something like this. Let's just say that you have a PDF or a Markdown text or whatever. Your Markdown text will look something like this, so let's just say there are a few pages of text. Generally speaking, if we upload the entire PDF in our vector database, the LLM always sees the first part of a PDF relatively clear and also the second part of the PDF relatively clear, but the stuff in the middle, yeah, this stuff is not that great. So the LLM will not be that accurate with this stuff in the middle. But we have something that is called chunk size. We can feed the LLM small chunks, and then these chunks get embedded. If we embed the whole document at once, it is a high probability that the stuff from the middle ground is not perfectly accurate. But we have, of course, the chance to make chunks of this text. For example, a chunk could be something like this, then this, then this, and that. So we have, for example, 4 chunks, and every single chunk right now is separately embedded in this vector database, and then the LLM can always search these chunks. This is an important concept that we need to understand. And the next important concept is that we can not only make these chunks, we can also make chunk overlap. Let's, for example, say that we have 1,000 tokens right now in this chunk. So the LLM will search, for example, for dogs, and let's just say the LLM find a lot of dog chunks or a lot of dog tokens in this first chunk. And maybe also something down here. So the LLM can be a lot more efficient and only searches this first chunk and this third chunk and will not take a look at this chunk. If we don't split these, if we don't make these splits, the LLM will search the entire PDF and the output will not be that great. The output will most likely miss a few chunks from here. But of course we can make these chunks, and then the second thing is that we can make chunk overlaps. An overlap simply means that we can also take this right here. So the first chunk would be, for example, this entire chunk until down here, but as soon as the LLM searches the second chunk, it will also search in this middle ground once again. So if there are some tokens about dogs right between these two chunks, the LLM can search these chunks a little bit more accurate. You know, every LLM has a token limit, and if the token limit is a little bit too small for our chunks, for example for the whole PDF, the output will be really bad. Yes, the token limit gets bigger and bigger and bigger with better and better models, but still chunking down these PDFs is important. And I want to give you some rules. If we go in a text, this would mean something like this. If I upload this whole text without chunking it down, the LLM will see most likely relatively clear what's in the last part of this text and also what's in the first part of this text. But if we chunk it down, for example, in 5, 6, 7 chunks, the LLM will always search one chunk, for example, until here, and then searches the second chunk, and the LLM can give us the most optimal tokens. And if we use chunk overlap, the LLM will also take a closer look twice at these chunks that are overlapping. This is an important concept that you need to understand. I want to give you some general rules. If we zoom in this text a little bit that I have written right now, it depends on the type. So of course it depends on what type you use. For example, if you have stories, you can use chunk sizes between 1000 and 5000 if the context window of the LLM is large enough. If you have a big model with 8000 tokens context window or 250,000 token context window, 1000 to 5000 tokens as chunk size is completely fine. If on the other hand you have shorter texts, shorter stories, shorter PDFs, between 500 and 1000 is perfect. If you have on the other hand items with lists and links, 100 to 500 could be a little bit better. And then the chunk overlap, roughly 1 to 5% is perfect. This means if you have a chunk size of 1000 token, an overlap between 10 and 50 is perfect. And generally speaking, you should play a little bit with these. Just play a little bit with these as soon as you make your rec applications, because we cannot say like this text you need 2500 and an overlap of just 20. You need to play a little bit. Every text is unique and you need to play a little bit. But generally speaking, lists, shorter chunk size, short stories, a little bit bigger chunk size, really long stories and books, here you can use really large chunk sizes. Now some more words on pricing, accuracy, and the size of your chunks and the context window. A lot of people have found out that the newer models have the context window really big. Let's just assume that you have a lot of data. So let's assume this is nearly a whole book. And let's just say this whole book has, for example, 500,000 tokens. There are models out there, for example, from Google, that have 1 million tokens. Yes, this is really true. We have models from Google that have a token limit of 1 million. And then some people tell us that we can simply upload these whole documents as one chunk. So we do not need to chunk this down. And I have to tell you something. Even if the accuracy would be good, let me tell you it's not, but let's just assume that the accuracy would be good, because Google has really strong models here. Google has the needle in the haystack test. Basically, Google can find a lot of good information, even if this thing would be just one chunk. But then this thing comes around, the price. I want to tell you that if you upload gigantic chunks, if you upload, for example, chunks that have like 50,000 tokens in every single chunk, you have the problem that the pricing gets extremely high. Now, why is this? Because you throw up all these tokens and the LLM need to process all of these tokens. So basically, if you send a query, every time 50,000 tokens get searched here. So you send a query that is gigantically high. If you have, on the other hand, chunks that only have 5,000 tokens, maybe you search like in 2 or 3 of these chunks, and then you have only 10,000 tokens that you send to the LLM. And the query will be a lot cheaper. So basically, you need to find the right chunking size. It will be cheaper, it will be more accurate, even if the model would allow you to upload bigger chunks. So basically, as soon as you are here, as soon as you upload stuff in your vector database, make sure to use the right things here. Of course, you use your Pinecone vector database, this is fine. You use the default data loader, it's fine. And then as soon as you use the character text splitter, this thing gets important. Here you need to type in the right stuff. So please just use the right chunk size and the right chunk overlap. Generally speaking, you know how you should type this in. 5% as a rough estimate for overlap. If you have just some basic numbers, you can also make an overlap of 0, then it gets even cheaper. And the chunk size, like I do not like chunks that are bigger than 5,000 tokens at once, even if you have like bigger stories, because we can work cheaper if we don't have this too big. So if you work with data that has numbers and is also relatively short, just use really small chunk size and also really small to no overlap. And then your rec application will work a lot cheaper. This makes a big difference, even if the accuracy would be also good enough with chunking sizes of 50,000, but this is like stupid. We do not want to pay bills that we don't have to pay. So you will be more accurate, cheaper, and also faster. Your rec application is also faster if you do not have to send out 50,000 tokens in every query. So 1000 is a perfect mix between stories and shorter texts, but maybe it's not optimal if you have items with lists and links. If you use items with lists and links, just go a little bit down. Generally speaking, you always have just a word and then the price, and for that reason the chunk size should be small, so that the LLM looks at this small chunk and find your price with this item immediately. So of course the chunk size should be small, and also the overlap is not really that important. And that's basically every single thing that you need to know about chunk size and chunk overlap. This is the next big thing that you need to know if you want to make a perfect rec application. So I think now you are perfectly ready to rock with your rec application. In this video you have learned that you should use the chunk size and chunk overlap correctly. Long stories, long chunk size. Short stories, shorter chunk size. Lists with prices or something like that, really small chunk size. The overlap, use something between 1 to 5% of the chunk size and you are ready to rock. This section was about optimizing. It was about optimizing rec applications. The first thing that you need if you want to have a good rec application is of course good data. You can ask other people for data, and if other people send you data, you will most likely get messy data. You can also search your data yourself, and if you get other data and search data, you can either make Q&As out of these or you make Markdown out of these. You can also summarize this data. And of course you have also the possibility to scrape data. The easiest thing to scrape data is to use the automation in NLN. You can simply scrape everything from a HTML web page. And if there is good content, you can also make it into Markdown. And if there are a lot of links, you can also extract all of these links, classify the links with AI, and scrape the sublinks once again, and then you can feed everything into a vector database. But before you feed stuff into a vector database, remember, always make Markdown. If you have PDF or other files, just convert it into Markdown. You can use LlamaParse, you can use Firecrawl, you can use Julia, you can use online converters, you can use a lot of stuff. As soon as you have Markdown, make sure that you don't upload redundant data. You can also summarize your data, and as soon as your data is in Markdown and crystal clear, you can upload it. Before you upload it, of course, make sure that you use the right chunk size, the right chunk overlap, so that your embeddings are correct. As a rule of thumb, bigger texts that are more like a story, bigger chunk size and bigger chunk overlap. Smaller texts, smaller chunk size and smaller overlap. If you work with numbers or sheets, really small chunk size and really small to no overlap. This not only makes sure that the LLM finds your information more accurately, it also makes your application faster and cheaper. So you have learned a lot in this section. You know how you can make really good rec applications. And you know what learning is. Learning is, of course, same circumstances but different behavior. Next time you build a rec application, please use good data, make the data in Markdown, summarize the data, use no redundant data, make Q&As if possible, and use the right chunk size and chunk overlap. Then you have a fast rec application that is precise and that is also cheap. And I also want to tell you one brief moment what good learners do. Of course, they learn together. So if you could share this course, this would really mean the world to me. Maybe it also means the word to the other person, and if the other person gets value out from this course, they will describe the value to you because you have told them. And so we have a win-win-win situation. And that's the goal of a course. So thank you for that, and I'll see you of course in the next section, because nobody skips the last sections of a course. We are nearly through it. See you.